and biology have a lot of things in common. Right.
Just kind of to throw this out there, when I took my Buddhism class when I was working on my bachelor's degree, we read a book by the Dalai Lama, and he wrote a book called The Universe in a Single Cell, or something like that it's called. And he talked about evolution, and he said that one thing that biologists have not talked about and really tackled, which he feels is important, and obviously he's coming from a Buddhist idea, is that where does altruism come into play? Because animals have shown that when a group is threatened, they will be willing to sacrifice or be martyred for the sake of the safety of the rest of their group.
Right.
And he gave a lot of examples, like a lot of birds will chirp out if a predator, it's going to come out and eat them, or even humans have shown altruistic, abilities. Where we had that example about it a few months ago, a year ago, where that teacher who his students were going to be shot, and he literally threw himself in front of the shooter so that he would be shot instead of having his students killed. And he feels that, in the book he indicates that evolution should not simply look at survival of the fittest as an important process, but that also altruism is also an important factor that we need to consider in group cooperation.
That's a very good point. And not just Dalai Lama mentioned it, actually being a long issue for, say, theory of evolution. Now, it's based upon selfish genes, right? Every gene works for the nutrient. How could it develop, altruistic traits? But recently, and not just recently, through 1960s, a lot of books, Richard Lewontin and Richard Dawkins actually promoted a very important account to explain how altruism is possible within a selfish gene framework. It's really, we understand, it's two levels. Really, we understand the level of individuals. But what really works in evolution is at the level of genes. What matters is not the individuals do. The individuals, you can see all those altruistic behavior, you can somehow explain them in terms of genetic interest. I'll give you two examples. So one is that, you can see in many species, also animal, human beings, mother could and often sacrifice the interest and often the life to save the young. Why do they do so? Individually, it doesn't make sense, right? But genetically, it makes all the sense. Because you make sure your genes will continue to exist. Even you sacrifice, but your young will be, able to reproduce in the future. Your gene will be preserved. So from the genetic perspective, it doesn't, have any value. So that's one story. The other story is that sometimes, from the group of birds, if one bird sees the eagle approaching, to predate on the bird, some birds just fly to the eagles to make an alarm to the other birds. So, gee, is the eagle coming? Then they make a noise and, make a pattern of flying. So for the eagle to not just notice the bird, but also to alarm the other birds that, the eagle is approaching. That's clearly a sacrificial, behavior. Why did the bird do that? One reason easily can explain that, because the group shares the same gene pool. And you can alarm the other birds to make sure the other bird can fly away, so at least notice that, the eagles are coming. And you still have a chance, right? Even you make sure, the eagle will notice you, but still you have a chance to fly. And it's better with the mother bird with baby bird situation. The mother bird actually try to catch those predators' attention because the mother bird has a better chance to survive. And sometimes even the fish injures. Come here, get me. But really, when the eagle approaches, they just fly away very fast. All this, it seems to be altruistic. But if you understand from the genetic point of view, it's very easy to see why they do so. All of these details, we have really made a lot of progress in biology and in sciences in general. And it's really sometimes a pity that many people don't know that until you read the books and understand it. It's something really the knowledge are there, just not being utilized. Daniel's book, the one reason I chose this book because it has so many different ideas. But the unfortunate thing is that many ideas have not fully explored. It gives a reference. So if you find the idea interesting and you find the idea not fully explained, go search for the references. Go read those other books, which are really detailed, really fascinating, really, could say, really revolutionary in some sense. Freed us. I'm certainly biased, but I think I agree with Daniel here. Really important to know who we are.
So just going back to the last slide
Okay.
and well, the idea of the selfish gene. So why does there's that question? Why was sexual reproduction selected? This doesn't make sense.
Yeah.
Isn't it
That's
easier?
another good example.
It's
Yes.
easier to just reproduce myself. I mean, what if I don't find someone? What if it's the wrong match? What if we don't fit?
Again, that's a problem, right? During the sexual reproduction, meiosis process, right? The DNA will be separated into two parts, right? With mixed, combination. I don't know how the process is done, but at least the outcome is that only one half of your genes will be able to be transmitted to the next generation, combined with other half from the other part. You have a risk, right? You have a very big risk for every gene, right? You only have one half of a chance to be able to be inherited to the next generation. Intuitively, that's stupid, right? No, I want to be certain that my gene will be there. But why did they do so? Eventually, many species, advanced species, are using the sexual reproduction instead of asexual reproduction. So why did they do so? It's an outcome of long-term evolution. One reason that is to increase the diversity of the group, increase the gene pool, the complexity of gene pool, and that gives you a chance to survive, a more chance to survive. If you have only one fixed gene pool, then an unfortunate event will wipe the whole gene pool out. But if you have diversity, then it's likely that you'll survive those natural diversities and still continue to survive. So in that sense, 1/2 chance of survival is better than 1.01, 0.1, or 0.1, or no chance at all. So that's the idea why, at least many people today believe why sexual reproduction are involved. Yeah,
But maybe I'm just misinterpreting this, but aren't you 100% likely to get at least the DNA from your mother through the mitochondria?
Some genes, yes. Certainly there are some genes, both from the X and Y, are only in X and Y. And even that, the gene is not necessarily there. It's just, okay, if you got it, you forgot it from your mother. But you don't necessarily got it, even your mother had it. So you still have a chance. But there are other genes which are really, we call that, I don't know what the biology call that, a dominant gene or whatever. Yeah. They will actually make sure they intervene with the meiosis process, make sure their genes will be always on board.
And also a lot of the recessive genes are, generally recessive genes are weaker qualities. So for example, even things that seem benign to us now, because we like blue eyes, because it's very harmful in certain climates to have blue eyes, for example, or nearsighted or whatever. And so, that you only get blue eyes if you've got the two recessive traits. If everyone had blue eyes, you'd have more blindness, as an example. There's obviously others that are fragile,
Those are
You
talk about recessive, that's not exactly how you mind. Recessive genes, okay, you have two pair of alleles, one pair of alleles, one gene, if paired with other allele, is not a dominant trait. The genes I'm talking about is that really, we have the DNA split. Some genes in the DNA will make sure that it always, happens in the process, be ended up in the next